Morning, everybody. Hope you're having a great day. Today is Codeforces, very next Codeforces round 718. This one's written by Mifa Favio, who, if you're not familiar, is actually like really good, like tourist level good. So should be fun. He's also very math heavy, so there might be some linear algebra going on here. Who knows? Good luck if you're competing. Commentary will be on a little lighter side because it's rated for me, and I'll be doing my work on paper. But here we go. Sum of 2050. Number is called the 2050 number. If it is 2050 times 10 to the k. Given a number n, you're asked to represent n as the sum of some 2050 numbers. Compute the minimum number of 2050 numbers required to do that. So if we use 2050, if it's not divisible by 2050, it's -1. Otherwise, it's 2050, or it's like x over 2050. And then we use each digit of 10, the sum of digits. Yeah, some of the digits, I think, yeah. So in this case, we say ans plus equals I minus 0. -1, 1, 2, 1, 2, 36. All right. How many test cases? 1,000. We should be good. Oh, it's div1 plus div2. Okay, I wasn't mentally aware of that, but that's fine. It's also a very long contest. All right, here we go. All right, we got A, on to B. The 2050 volunteers are organizing the run. Oh, that's why it's contest 2050, I see. Run, chase the rising sun activity, starting on April 25th at 7:30. Runners will complete 6K. Who runs a 6K? 5Ks are where it's at. N plus 1 checkpoints, numbered 0 to n. You go from 0 to n, you have to pass through each checkpoint. Between any two adjacent checkpoints, there are m paths. Okay, so for this one, runner choose exactly one of the m paths. The length of the jth path is bij. Okay. To test the trail, we have m runners. Each runner must run from checkpoint 0 to checkpoint n exactly once, visiting all checkpoints. Every path between every pair of adjacent checkpoints needs to be run by exactly one runner. If a runner chooses the path of length L, his tiredness is the minimum. So here you have 3 runners, so you do like 4, 1, 3, 3, into 5. Yeah. Okay, so you like have to assign each thing in this group to each thing in this group and so on until you're done. So you care about the k smallest things in the graph or in this grid. That's all you care about. Or the m smallest? The m smallest. Yeah, care about the m smallest things. And then you put one of those in each column. So this, and this are the m smallest. Okay. So yeah, we're swapping them is going to be, I don't know, a little difficult. That's fine. So this is height and then width. Okay, let's just call this all of them, and then go. Sort them, sort all of these things. Okay, so now we want the first W to be moved to their correct spaces. So how do we swap these two? Yeah, okay, so we get these, then we want to say a.y equals y2, b.y equals y1, and then same thing with x's. All right, now we need to actually set them. So board at x1, y1 equals b, board at x2, y2 equals a. All right, and then we need to, yeah, I guess we need to print them. All right, so now for int I equals 0, less than width, I plus plus. So we want the position. All but get I, and we need to move this to row I or column I. So if cur.x equals I, continue. Otherwise, swap board cur with spaces at, or swap spaces. Current spaces at the new x will be spaces at I, or spaces at, yeah, I, and then cur.y. Then print it. So print these things, print a new line. I think that's it. All right. For 1, so what are the smallest values? 1, 2, and 3. Yeah, so the answers are 1 plus 2 plus 3. This is 1 plus 2. Yep, I think we're good there. Do we need print writer? 100 by 100 by a lot, yeah. Oh, the sum is 10 to the 4, so we print 10 to the 4 things? I guess we're fine then. Or, yeah, I guess should be fine. Not bad, not bad. Philimo 2. Sounds like dominoes. Okay, in one classroom in this town, some volunteers are playing a board game variant of something. Consider an n by n chessboard. Its rows are numbered from 1 to n, columns also from 1 to n, left to right. So top to bottom, left to right. Okay. A cell on the intersection of the xth row and yth column is xy. The main diagonal of the chessboard is the cell's, permutation was written on the main diagonal. There's exactly one number written on each of the cells. The problem is to partition the cells under and on the main diagonal into n connected regions, satisfying the following constraint. Okay. Each region should be connected. The xth region should contain cell XX. The number of cells that belong to the x region should be x. Is it impossible ever? It's never impossible. Glad we know. Okay. Let's think about that for a minute. Yeah, the sum is always going to work out, right? So we can say, like, anytime the sum does work out, we're set. Otherwise, the sum for the prefix is too big. Yeah, okay, it's easy. So you have the main diagonal, then one of the things is a 1, so you delete the 1, everything else goes to the middle. Yeah. Alright, how do we implement it then? So it's always possible. I have a proof it's always possible. Oh no, what have I done? Okay, let's just make a new one. It's always possible. I guess we can just solve it with an array of size n. So then, yeah. So we'll solve it, then we need to print the answer. How big can this be? 500 by 500? Print writer it is. Line and close, system.out. All right, in this case, we have, so we need to print everything in this row. So out.print board at xy, and then if x is not equal to 0, out.print a space. So this should be what we're looking for. Good. So now we just need to solve this. So we need to fill the main diagonal. So the x will be I. The y will be turn plus I. Then board at xy equals a at I. All right. And then we want to, okay, so if a.length equals 0, then return. Otherwise, we need to find the biggest things. Yeah. So int min equals a at 0. Mindex is a cool word. So if mindex is, if a at mindex is less than, greater than a at I, then mindex should be I. And then we want to say remove mindex. Yeah, okay, looks good. I love how they made pictures for this, as if it wasn't obvious how to how to read this board here. Okay. Yeah. I think we should be good there. N's always 1. I guess let's just try the 1 case. Yep. Looks good. Submit C. I guess standings really don't matter at this point. It's way too early for it to matter. All right, you're wandering in the Explorer of Space in the 2050 conference. Or the Explorer Space. The Explorer Space can be viewed as an undirected, weighted grid graph of size n by m. The set of vertices is all I and j. 2 vertices are connected by an edge if and only if. Yeah, all right, sounds good. What is the weight of the edge? I guess we don't know yet. Okay. At each step, this is like also very mathy. I think like this is gonna be, if I hadn't been doing this for a while, this would be very difficult to read. So I don't know that I like this wording on behalf of the people who don't know like what all of this stuff means. Anyway, at each step, you can walk to any vertex connected by an edge to your current vertex. On each edge, there's some number of exhibits. Since you already know all the exhibits, whether you go through an edge containing X exhibits, whenever you do that, your boredness increases by X. For each starting vertex, please answer the following question. What is the minimum possible boredness if you walk from IJ and what is the minimum possible boredness if you walk from IJ and goes back to it after exactly k steps? Just verify that I'm right here one more time. Yeah. You can use any edge multiple times, but the boredness of those edges is also counted multiple times. At each step, you cannot stay at your current vertex. You can also not change direction while going through an edge. If you walk from this place and go back to it after k steps, so you basically just have to take k steps, up to 20 steps. We have to print the answer for every vertex. No, so what is input? We have, this is the, so this is if you go right, and then this is if you go down. So everything has cost 1. For each thing, if you take 10 steps, the total distance is 10. Looks like our runtime to me. Yeah, so if we have dp at x, y, time, you have some pretty boring choices, I think. Oh, you have to go back to it. Yeah. So what if k is odd? Yeah, if k is odd, it's -1 for everything. If k is even, yeah, so it's undirected, right? So if k is even, you're going to take some path and then take that path in reverse. Otherwise, k is odd. Okay. All right, so maybe a mildly interesting problem, I guess. They did it to us. Brutal. If you're doing a thing where samples is a grid, make these differ in at least one place. All right, n is the height. I'm going to assume n is the height. Then one test case. Yeah, okay. So we have this cost, right cost equals, and then we also have k. So if k mod skew equals 1, all right, so if it's odd, then we print -1 for everything. Yeah, okay. Otherwise, we have these inputs which we have to read. So we have int array right cost equals new int array. So this is x minus 1 by y. The xth region should contain cell XX, should be the x region, should contain the cell on the main diagonal with number x. That should be width -1, height -1, height, width. Right cost at xy equals the next int. Okay. Then we're going to do the same thing. Oh no, I've reversed the order here. We read in y then x. Same thing here. This goes to height -1. This goes to width, and this is the down cost. All right, so we need a long double array dp is new long width by height. So this is if you take 10 steps and end here. Yeah, which is the same as like you could do those steps in reverse and then do them forward. Yeah, okay. All right. So x is 0 less than with x plus plus. X is not equal to 0. Dot print a space. Dot print 2 times dp x y then print line. Yeah, because we go forward and go backward. Right. So if you take 0 steps, you do that. If you take 1 step, is this, yeah, so we do this, yeah, okay. All right. So we just need to process this now. How do we process it? Okay, so each dp next we could hit by going right, left, up, or down. So dp at x, okay, so if x is not equal to 0, ans equals math.min of answer and dp at x minus 1y plus right cost at x minus 1y. Yeah. Okay. If y is not equal to 0, ans equals math.min of answer dp of x y minus 1 come from above. Is down cost. All right, if x is not equal to width minus 1, it equals math.min. So this is x plus 1 plus right costed xy. Yeah. Down cost is not equal to height minus 1 and then width minus 1. Okay, otherwise we come from y plus 1 and then down cost of us. Yeah. All right, we do that. We switch the dp tables and then we keep going. All right, I think we're good. Four, 4, 10, 6, okay. All minus 1s. We're doing this in the right order. Height, then width, yeah, I think so. RTE. Darn it. All right. This is why you test sample or test things more than samples. 2, 1. Let's take 2 steps. All right, let's say 2 by 3. Okay, so what does this mean? This means height is 2. Width equals 3. So if the first thing is go right? Is it the right cost? Yeah. Okay, so we do 1 row of that. So let's say it's 1, 1. And then this is the down cost, 1, 1, 1. Height minus 1 width minus 1. So why did this take 4 things to read in? I is less than 2, yep. Oh, the width should be 3, yeah, okay. So it needs to look like this. Ah, man. Silly mistake. And I'm going to pay for that too in penalty. All right. Oh well. Yeah, we're not doing too bad. So, all right, here's where the contest starts, ladies and gentlemen. We finished the speed run, now we start the thinking. All right, in the 2050 conference, some people from the competitive programming community meet together and are going to take a photo. The N people form a line. They are numbered from 1 to N, from left to right. Each of them holds either a C or a P. Let C be the set of people in sorted order who hold C, and P be the same thing with P. A photo is good if and only if the following constraints are true. Everyone holds one thing, no one holds both. The difference between two adjacent things what do these mean? Can I not just explain it? Okay, this thing minus this thing. So the difference between two adjacent things, if I is 1, this, oh, okay, so if I, yeah. The difference between these two is less than or equal to the difference between these two. So the C's get more and more spaced out. And then the P's, so the first difference, the P's get less spaced out. Okay, so yeah, the differences between the C's increases as you go right, and P's decreases as you go right. Given an array, find the number of good photos satisfying this condition. Sum of all of the C. Whoa, what? Okay, this is an insanely ugly problem. Let's try another one. Supported in 2050 conference will be held in Yunqui town in this place from this place. Okay. Anyway, on to the problem. The relationship between the n volunteers of this conference can be represented by a tree. Numbered 1 to n. We define the distances between two nodes as the number of edges on the shortest path of the tree. Distance, from something to itself is 0. Okay. Some volunteers can attend the on-site reunion while some others cannot. If for some volunteer and some non-negative integer, all volunteers whose distance to x is no more than r can attend the on-site reunion. A forum with radius r can take place. The level of the on-site reunion is the maximum possible radius of any forum that can take place. Assume each volunteer can attend the on-site reunion with probability 1/2, and the events are independent. Output the expected level of the on-site reunion. Oh, so if everyone can attend, then it would be like infinite. Interesting that it's n and not just like the size of the... Yeah, anyway. Okay. Not the diameter. Yeah, that's really weird. This is like a very weird definition. This is 1/2, I assume? Yeah. So this seems plausible. The thing with E, okay, E's got some solves. The thing with E is that I don't think there are many ways of like doing it. Like the condition is pretty stringent, I think. Okay. What is this saying here? So the C's get more spaced out. The P's get less spaced out. So if you ever have two P's next to each other, then this all needs to be P. And then if you ever have two C's next to each other, then this all needs to be C. Like everything to the left needs to be a C. All right, now what's the question? Given an array, find the number of good photos satisfying the following condition. The sum of the things that are C is less than the sum of things that are P. I guess let's write a brute forcer to look at all of the ways there are to do something. In butts. Okay. Yeah. All right, so what do we want to do here? Alright, so if next minus now is greater than now minus last. Alright, so now we have all of the cases, and now sys out. I guess just go through it. "32 ways, that's not good." Oh, wait, maybe it is. What if it's 10? 2 to the 5? All right, let's look at these. So we can have prefix of zeros and then a bunch of ones. I guess this is the tricky part. You have stuff like that. This is a bunch of ones and a bunch of zeros. And then we have some confusing stuff. And then we have, yeah, we've got like this. What if this is like 25? It's probably around n squared. Yeah, it looks like most of the time you either have all zeros, you have one zero, you have all ones. So all zeros, some ones and zeros. Question is how many ways? Printed under mod. Probably don't need a mod, but anyway. There are a lot of things you can't have. Like there aren't that many arrays to consider here. These two constraints are very restrictive because everything can only be a C or a P, right? So if you ever have like a 1001, you need like a lot to be the case. If you have 100, if you have multiple zeros here between two ones, you need to alternate 10 after. Or it'd be all ones maybe? Can it be all ones? Yeah. So then everything, this either has to alternate or be all ones. Okay, so I guess we find all of the ways of doing this. Cliff Bar time. All right, so yeah, maybe this is confusing because we're doing like lexicographically last. So let's make like, let's go. Yeah, okay. So if you have 0, 0, after that, you can have some things. You can have one, like you can have repeated zeros, and then you can have some ones. One, zero, 1, 0. Or you can have 0, 0, 0, and then 1, 1, 1, 1 forever. Those are your two options. Yep, so you can do this for no, that's not the case. You can have all ones with one more 0 too. But you can never have 2 zeros unless it's every other. Yeah, okay. I think that's it. Can it be, oh wait, can it be anything? It can't be anything, no. This one extra 0, wait, why does this work? Okay, this is kind of wacky. You have a bunch of zeros. Can you have a prefix of 1010? Okay, so you have a bunch of zeros. And then you have some 1 0 1 zeros. And then you have a bunch of ones. So that's what like a lot of these look like. Like this one, you've got some zeros, some 1 zeros, and a lot of ones. But the last thing can change? Why just the last one? Oh, maybe, yeah. Because the last one doesn't really matter. As long as this is a 1, then last can be 0. Okay, so that's everything. So you have prefix of zeros, always. Oh no, but you can also have the reverse. So you can have a 1 in the beginning if the second thing's a 0. So if this is a 0, then this can be a 1. Oh boy. Oh boy. Oh, lots of cases. Okay. So if we like brute force the first 2 things and the last 2 things, we can figure it out. So yeah, it's going to be some prefix sum shenanigans and some other stuff. Okay. So it's 14 solves. We'll get it eventually. It's going to take a while, though. Is the person with F doing well at all? Or is it just like a random guy? Looks like it's a random guy. I'm not worried about it being super easy, though, because Tourist has had some time and hasn't gotten it. So, sanity check is it's not hyper banger. Sorry about that. Work-related stuff. Yeah, all right. So E is a strat. It's just a matter of doing it. Okay, so let's say we ignore the first two. If we ignore that in the last two, then everything we have is a bunch of zeros. We've got a bunch of zeros, some 0, 1, or some 1 zeros, and then a bunch of 1s. And then the sum needs to be at least whatever. So yeah, okay. So we can say like pick 1s where the sum is at least whatever. Yeah. Or pick, I guess. Yeah, pick 1s where sum is at least. Right. How many ways are there to do it? Okay, cool. Cool. All right, this isn't multi-test case. It is multi-test case. Brilliant. How many test cases? A lot. Is that going to be a problem? I don't think so. So I think that's all we need here. Yeah. Do we want this to be a long array? Values are up to 10 to the 9. I guess int array doesn't hurt, I think. Okay, so let's say assume that we pick zeros for all positions. Then if we pick a 1, we get 2x the points. And then we need our total to be more than sum of the array values. Okay. Cool. Good. So if n is less than this, we can brute force the mask. I guess this is pretty simple, right? So if n is less than 4, are all these values positive? They are. Okay, if n is less than 4, n is 1, we have, I guess let's just try this. Okay, what if n equals 2? Is this a strict less than? Okay. If a at 0 is less than a at 1, lays plus plus, then we have 1 and 0. So otherwise, if n equals 3, we have all of the things. Yeah, they're all of them. Oh, I guess there's a much easier way of doing this then. So that handles all the small cases. All right, otherwise, these all need to be longs. Okay, so yeah. So if we have 0, 1, and then it ends with 0, 0, that's impossible. Starts with 0, 1, 0, 0 is impossible. And then also, if it ends in 0, 1, and then it starts with 1, 1. Yeah. If T0 and T1 and not T2 and T3 continue. So if T1, then Alright, so we might be forced to start with a 1 or forced to end with a 0. This is kind of gross. Okay, so we have these. Everything else is possible. Yeah. So we should be good. I think. We just need the total. Okay. So, long target total. Sum real equals target sum. So if T1 or if T0 target sum real minus equals A0 T1 then this is T2 and T3. This is A at n minus 2, n minus 1. All right, good. And then we have ways equals add ways to solve. We want to pass in the middle array. N is n minus 4. The min sum is target sum real. Forced start with 1. And forced end with 0. Okay. This is all we have left now. All right, cool. So what do we need? We need the number of ways of picking stuff that is legit. So we're going to need the sum of every other and then the sum of everything. Yeah. All right, so we need point add and then range sum less in some like implicit segment tree. How much time do we have for this? 1 second. You're kidding me, man. Yeah, we need how many things are less than. So annoying. Okay, yeah. Now we need public void add. Things in just plus. LEQ. All right. If vals greater than or equal to rightmost, turn things in. If vals less than leftmost, turn 0, turn child dot query LEQ val plus child dot query LEQ. Good. All right. So now we need make kids, and then we want to say, what do we do here? Okay. Then okay, so int mid equals leftmost plus rightmost over 2. Child equals new seg tree from leftmost to mid. Our child equals new seg tree from mid plus 1 to rightmost. X is greater than or equal to, or is greater than, less than or equal to L child dot rightmost. If X is less than or equal to left child dot rightmost. Then L child dot add X, else R child dot add X. Okay. Needs to be a long. This might not be query LEQ, might be something else. Okay. All right, so we want to brute force the point that we're considering, the X we're considering. So we have a bunch of zeros, then a bunch of 1 zeros, and then a bunch of 1s. So we're going to brute force this split point. Then we're going to add to the segment tree. And then we're going to query from the segment tree. So add to the segment tree means start 1 0 section. Query from the segment tree means stop the 1 0 section and then start the 1 1. Start all 1s. We want an even and an odd. problem is taking a long time to implement. Yeah, I think I'll be able to get it, but it's just annoying. What do I need to get back my IGM? Quite a bit. I need like plus 80. Maybe if I get this problem. We'll see. Implementation. Okay. How do you do this? Okay, so you have this split. So we're going to consider every position in this array. Oh, this is just the same as like, there's one place where you start getting all of the even indices and one place where you start getting all of the odd indices. Yeah. Yeah. And those are totally independent. Okay. Oh, so now we don't need a cool, we don't need this segment. I just spent a bunch of time writing the segment tree, which we don't need. Because we can do binary search on an array. We can sort the array, then binary search, yeah. Which will be faster overhead, probably. I think we don't need any of this either. Okay. So, the question is, actually we might need this. It's probably going to be just helpful to have. Okay, so what if forced one before is true? So if forced one before is true, then that means that start odd equals 1. Okay, what if forced 0 after is true? What does that mean? So that means that if n is even, we never take odd, or yeah, start odd never happens. If n is odd, what if n is odd? What does that mean? Okay, so 1, 2, 3, 4, 5, and then we have a 0. Then this isn't start odd, this is start even. Start odd. Whatever happens. So if forced 1 before and forced 0 after and n mod 2 equals 1. Okay, well, first of all, hang on. So if n is equal to 0, and return 1. It's just one way of doing it. Oh, now I have to do min-sum logic. Okay. If n equals 0, if min-sum is less than 0, return 1. What if min-sum is equal to 0? Then no. Yeah, okay. All right, min-sum is less than or equal to 0. Then return 1, otherwise return 0. What if n is equal to 1? Well, I guess we'll see. Yeah, okay. All right. Otherwise, we have our things. Okay, cool. So what do we need here? We need long array A, Boolean, start, a Boolean, forced 1 before, Boolean, forced 0 after, and then return. Okay. So for long Allen odd start values, long array A long min. Okay, so if A at length minus 1 is greater or is less than min value, turn 0, 0, max equals A.length minus 1. So the target left will be min sum minus L. Oh, this is not A. This is even start values. Yeah. Okay. All right. Good. So we're good here. Problem is that these just don't work. Okay, so this is an int array. This is an int array. Now we just have to implement these. Okay. So they're forced 0 after and n is even. N mod 2. Okay, in this case, then we never have if we have a force 0 after, okay, then yeah, then we don't get to pick anything. Otherwise, we're free. If it's 3 long, you can include 0 or 2. If it's too long, you can include 0 or 2 things. So length plus 1 over 2. Okay. Arrays gives me 1 choices. All right, so now what happens here? So if forced 0 after, well, this doesn't matter. So this is just if forced 1 before, then we have to pick everything. Yeah. Okay. Otherwise, free to pick any suffix. This is not right. This is a suffix of even indices. Yeah, okay. So long sum equals 0. And sum minus equals AI. Yeah, so include this and then remove this thing from your sum. Okay. Any suffix of odd indices. There are 3 things. You can take nothing. You can take just the middle one. If there are 4, you can take nothing. You can take this. You can take this. No, so it is over 2 plus 1. Yeah. All right, if there are 3 things, you can take 2. You can take wait a minute. No, if there are 3 things, you can take 3 choices. Three plus 1 over 2. Yeah, if there are 3 things, you have 3 choices. What about this? Okay, and this, if there are 3 things, we're picking odd indices. So if there are 3 things, you have 2 choices. If there are 4 things, you have 3 choices. Yeah. Res I over 2 plus 1 equals sum minus equals 8i. I think we're done, ladies and gentlemen. How far did we drop? Very far. Nope, wrong problem. So I say 8, the answer is 7. Continue. No, what? Okay, we get the first one wrong. So we should probably write a brute forcer for this. Yeah. All right, so this is n. Okay, we also need the sum of zeros and ones. So it's 10 ways. Good. All right. And we say there are 9 ways. So we have 0, 0, 1, 1. This gives us 1 way. We have, okay, we have 1, 0, 0, 0. This gives us 1 way. Oh, wait. Yeah, it's fine. We have 1, 0, 1, 0. This gives us 1 way. We have 1, 0, 0, 1. 1 way. We have 1, 0, 1, 1. Gives us 1 way. 0, 1, 0, 1. Gives us 1 way. 0, 1, 1, 1 gives us, oh, that doesn't give us any, so ignore that. Uh, 1, 1, 0, 0 gives us 1 way. 1, 2, 3, 4, 5, 6, 7. Ruh-roh, which one gives us 2? 1, 0. 0 or 1, 0, 1, 1. This gives us 2 ways. Okay. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. And then we also have the 1, 1, 1, 1 gives us 1 way. Okay. Yeah. All right. So what does that tell us? We need to figure out why that's wrong. Which one are we missing? 0, 0, 0, 1, 1 gives us 1 way. Yeah. Okay. What about 0, 1? There are 2 things that start with 0, 1. We only count 1 of them. So there's 0, 0, or there's 0, 1, 1, 0. There's also 0, 1, 1, 1. We're missing one of those. So this is 2, 1, and then 2, 3. 2, 1 is 0. 2, 3 is also 0. print equals first mass equals 2 and end mask equals 3. Okay. Oops. Yeah, I have to go to the bathroom. Be right back. Okay. Yeah, I'm pretty sure we just don't need that. So if print yeah, okay, that makes sense. So we do need to pick it, because if we don't pick it, then we get passed. So we need a sum of at least 2. We're going to get a sum of 4. All right, so this is wrong. Why do we have forced 0 after? We shouldn't have forced 0 after. Not T2. 11, that's now too big, right? It's 10, yeah. Man, that's annoying. Okay. All right, let's fix this. So 0, 0, 0. paper. We're getting very close, I think, unless we're like missing an entire case. But we have half an hour to figure it out, and then there's no way we're getting the next problem. Difficulty curve is too much. Yeah, so, we're getting killed because it's so easy. But yeah, we should be able to get this, and then we won't worry about that. And that's our contest. Lots of wrong answers. Lots of wrong answers in TLEs. We've a brute forcer though, so I'm not that worried. Okay. 0, 0. End mask is 1, 0. Let's only worry about the things we get stuff for, like we decided earlier. Okay, 0, 0, 1, 1. This gives us 1. One, 0, blank, 0, 0. This gives us 1. 1, 0, blank, 1, 0. Gives us 1. 1, 0, blank, 0, 1 gives us 1. 1, 0, blank, 1, 1 gives us 2. 2. Okay, so 2 is 0, 1, blank, 1, 0 gives us 1. 1, 2, 3, 4, 5, 6, 7. Oh, we have more? Yep, okay. 0, 1, blank, 1, 1 gives us 1. And 1, 1, blank, 1, 0 gives us 2. And then we also have 1, 1, blank, 1, 1, which gives us 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, why are we wrong? So 0, 0, there's one way, so we're set there. Okay, what about the 0, 1s? 0, 1s, there should be 2 ways. We get both of those, so those are right. What about the 1, 1s? There are 3. In total, we have 3 as well. All right, so then there should be 4, but we pick 5 of these. Is that right? It's true. 4, but we pick 5. Okay. So you'd end in, you cannot end in 0, 0. 1, 0, blank, 0, 0 is impossible. So your sum can be big enough if you take it. Yeah, so it's not allowed is the problem. So there is a 0 after. 0 after is true. There isn't a 1 before. Oh, this is annoying. Okay. 22 minutes left. One zero. One zero zero is not possible. Because the zeros get less spaced out. So my initial thing of like, okay, you can ignore the first and the last one. It's not quite true. Man, that's annoying. Okay. If you end in 0, 0, So if you end in, so special case if you end in 0, 0. If you end in 0, 0, you need to be this is bigger than or equal to the target sum, then end in 0, 0 ways plus equals, or ways equal, yeah, end in 0, 0 ways plus. Okay. 0, 1, 1 is 1. 1, 0. 0, 0. This is now there are no ways to end in 2 zeros. Why can you not just pick the last 2? You have this right here. Yeah, you've got this way. There's 1. Okay. Okay, the 2's. So 2's are 0, 1, right? Yeah, they're 2 2's. Okay. So then the 1's, in total we have 4 now. We used to have 5. Oh, the problem is with the 3's, I guess. Oh, man. Okay. So the 3's are wrong. So this ends in 0, 0. Okay, all 1's, there's one way of doing that. Ends in 0, 1. Yeah, so this should be one way of doing 1, 1, blank, 1, 0. Why is that? Because if this is a 0, try it. I guess we might as well just run the brute forcer because it's likely wrong. Okay, so 6, 1, 4, 1, 2, 1. Okay. For real? Okay. Alright, so there are 32 ways. Oh yeah, this doesn't work. One, two. So yeah, they're like 3. So all 0. Yeah. So I think it is. Wait, it is right. I think it's right then. Continuous ways is this. So 3, yeah, that should be right. So there should be 3 continuous. 3, 3 minutes. Oh no. So there are, yeah, there are 3 continuous. Okay. All right. What else? So first mask is, so 0, 0, 1, 0. There's one way. 0, 0, 1, 1. There are 2 ways. Yeah, this should be 1. I see. Maybe this is more of a DP problem. Yeah. Being way too caseworky at the moment. Guess there's a bug somewhere. Something I'm doing is wrong. Yeah, I don't know. Unfortunate. How my friends do. Nice job, Monaghan. Well done. And Spencer Compton, Anton. Good job, everybody. Yeah, I didn't do too well. Oh well. Keep my red though, right? Yeah. Unless I fail system tests. Kind of unfortunate. I can go over solutions for A through D, I guess. That'll be pretty brief. But, yeah, so for problem A, like, if the number isn't, so every number that you add is going to be some multiple of 2,500. And you're going to add 2,500 a bunch of times, right? And then you want to get to this result. The thing is, you can take 10 steps at once. So what you can basically just do is, it's possible to add this number a bunch of times, just one at a time. And you can figure out how many times you'd have to add it one at a time just using division, right? So if your answer is this times 10, then if you just added this once at a time, you would have 10 moves. But you can do 10 moves at a time, or 100 moves at a time, or 1,000 moves at a time. So you just take the number n divided by this, and then you take the sum of the digits in base 10 of that. So here's what that looks like. So I just like turn it into a string, iterate through each character in it, and then find the sum of those digits. Obviously, if it's not divisible by 2,500 or 2,050, then the answer is no. Okay. Cool. Morning jogging. So yeah, for this problem, basically you have a grid, and then you want to rearrange the rows of the grid so that the sum of the minimums along each column is as small as possible. You can just find so if you have, like, let's say you have m rows, if you find the m smallest numbers in the array, that'll be the answer. Or the m smallest numbers in the matrix, that'll be the answer. Then you just have to swap things around so that in the first row is like the smallest thing, second row second smallest thing, third row third smallest thing. Other than that, nothing else matters. because that's obviously the best you can get, the smallest m numbers, because you can only use each edge once. To code that, you can store like some space object and then have some way of swapping each space. And then you sort your spaces by values, and then you get the smallest m of them. I call it w for width. And then you shift it into the correct x coordinate here. Yeah, so that's the idea. And that'll get you the smallest m numbers, 1 in each column of your matrix. All right, problem C, Philemo 2. What was this problem again? Yeah, so you have this permutation. So here's the idea for the permutation problem. You have this series of permutations. So you've got like some permutation along a diagonal. Maybe it's like 1, 3, 4, 2. What you want to do is you've got these squares here. And this is like I actually thought this was a really neat problem. You want to like assign each thing a connected component so that it works out nicely. So you might do something like this. So this is your 3, maybe this is your 4. This is your 2, and then this is your 1 here. So each thing, the number of, like the size of the connected component is equal to the number on the main diagonal. In order to do it, there's actually a really easy construction, which is, if you've got, we'll do the same permutation here. If you look at this main diagonal, we have 3 numbers here. There are 3 possible spaces. So one of these things is a 1, right? This one's a 1, which means the 1's going to stop here. The 1's forced to stop. Everything else needs to take 1 space, and there's only 1 space left for each other thing. So in this case, you have the 3 go to this position, the 4 go to this position, and the 2 go to this position. Yeah, so basically you just take this permutation, you remove the smallest thing, and then you insert the remaining elements in the spots over here. So we'll do the same thing again. So now we have, I guess we'll draw these in blue. You've got these 2 spaces. So you're going to remove the 2 here. So the 2 just has those 2 spaces. You put a 3 here and a 4 here. And then we have one more time. We find the smallest thing. It's a 3, remove it, and then put the 4 here. So each layer, we need to remove 1 thing, because as you go down 1 more diagonal, it gets 1 smaller. You also remove 1 thing. All right, cool. So that's C. Then for D, you have this graph. So you have like a grid, basically, where you have costs of going left and right and up and down from each space to an adjacent space. And you want to take up to 20 steps and then end up back at the same position you started at. And you want to see for every position, if you take the same number of steps, what is the minimum cost to take that many steps and end up where you started. And then also it might not be possible, obviously, because if you have to take 1 step, you're not going to end up where you started. In fact, what you can do is if you take some grid, right? Let's say you have some grid like this. Oops. If you have a grid like this, what you can do is 2-color the grid. So if you imagine it's a chessboard, these spaces would be, I guess, white. Chessboard is even by even, but nevertheless. Those would be like white, and the other ones would be black. You can notice if you're on a space, every time you take a move, you switch which color you're on. So here, now we're on a black square, which means if you take an odd number of spaces, or odd number of steps, you're going to switch the color. So if k isn't even, it's going to be impossible. If k is even, then you're going to take some number of steps. You want to do it for the minimum cost, and then you're going to wind up coming straight back. Right? Because if that was the minimum cost to get from here to here, since every edge is symmetric, the minimum cost to go back is going to be the same thing in reverse. So if k is even, you just do the dp to take k over 2 steps and then multiply your answer by 2. Because your answer is going to be go somewhere and then follow that same path backwards. The dp is pretty simple. It's just like if you do a dp for which position you're at and what time you're at, that's equal to the minimum cost. So there you go. I did it iteratively because I was a little bit worried about time, but you probably can just do it recursively if you need to. That's the solution. Yeah, all right. Problem E. Honestly, I don't know well enough to be able to explain to someone who doesn't understand it. You have these interesting constraints, which means there aren't that many different forms of things you can get. I think probably the better approach to doing this is to do a DP. So you can do a DP saying like, have you seen a 0? Have you seen a 1? Have you seen 2 adjacent 0s? Have you seen 2 adjacent 1s? And then have you seen like a 0 with a space and then a 1 and like a 0 and 2 spaces and a 1? So, or like a 0 and then 2 spaces and a 0. So if you have like all of those things in your state, you can figure out what you can place next. The key observation here is that you're never allowed to do something like this. Like you can never do 1 0 0 1 0 0 1. Because like here you have a gap of 0 and then 1 and then 0. So you have like a continuous gap of 2 for the 1s, but that's not allowed because like you have to fill it in with 0s. So if you're going to continue alternating like this, the only thing you can really do is go like this. You can just continue alternating with 1s and 0s. So like if you're looking at a long continuous range, the only choices you have are all 0s, all 1s, or like a bunch of 1 0 1 0 1 0. Yeah. So the DP is also kind of tricky though because you have the constraint of like the sum part, but maybe the DP doesn't work then. Maybe you do have to do what I'm doing here. Yeah, okay. I'm missing some cases, so it's kind of messy. But this is interesting. Yeah, I don't know. I'm surprised how some people got it so fast. I guess it wasn't that fast. It took them like 25 minutes, but I spent, what, 2 hours on it? Still didn't get it? Anyway. All right, that's all for me. Yeah, not a great contest. I'm going to take a rating hit. But, yeah. Maybe I got unlucky. Maybe I just did badly. But there's always another contest, right? Are there any upcoming ones? Any upcoming Div 1s that I can do? Global round, May 2nd. All right, well, I'll see you then. I guess I'll see you on the educational one, too. All right, thanks for watching. I hope you did well. Hope you did better than I did. Have a great day. Goodbye.